In a flow volume curve, the initial portion is effort dependent, whereas the later portion, irrespective of the effort, was effort independent. Now, if you see both these flow volume curves, let it be whatever was the initial effort, the final phase was similar. It means something powerful is limiting the maximum flow rate at a given volume. This factor is referred to as dynamic compression of airways. Reason behind this is development of equal pressure point. Pressure inside the lumen of airway and the pressure outside the lumen was same, which was resulting in compression and airflow limitation. Now, if you notice in the first image, in normal expiration, you can consider intrapleural pressure, the outside pressure, as minus 5 cm H2O, whereas the atmospheric pressure is 0, even though the intraalveolar pressure can be plus 1 cm H2O. For convenience, I have taken it as 10 units so that it will be easier for you to show the reduction in pressure gradually. See, the final motto of any expiration is to equalize the pressure with atmosphere. In a normal individual, as air flows from the alveoli into the airways due to frictional losses, there can be reduction in pressure. In a normal individual, this is very gradual. A normal individual, as outside intrapleural pressure is low, always negative, airways remain open and flow continues. Whereas in forced expiration, in a normal individual, the intrapleural pressure can become positive, say for example 20 cm H2O as shown in the second diagram. The intravalvular pressure may start with plus 35 units. As time progresses throughout the airway, this pressure will have a gradual drop, but because the outside pressure is positive in the pleural cavity, there exists a point where the intraluminal pressure is slightly less than the extraluminal pressure, that is intrapleural pressure. And you can see at a point where outside the pressure is 20, within the lumen it is only 15, and this can result in dynamic compression of airway. But in a normal individual, this equal pressure point is not exaggerated as it happens in the cartilaginous proximal airways. Notice in emphysema, due to damage of elastic fibers, the drop in pressures may be very rapid. See now, the alveolar pressure was 35 initially and suddenly it drops to 28, then to 20. Because of this, the equal pressure point will happen early in the small airways. That results in exaggerated closure of airways at tidal breathing itself. The concept here is, in a normal individual, also equal pressure point happens, but it happens in the proximal airways which are supported by cartilage, so the compression is less manifested. Whereas in emphysema, due to damage to elastic fibers, loss of recoil, there will be early drop in pressures and equal pressure happens in the small airways which are not supported by cartilage, and there will be exaggeration of this dynamic compression.